Alright class, let's look at another equation from 8.3, another one that's quadratic in form, but we have a couple of different quadratics here. We got a cosine squared and a sine squared. So what we have to do in that case is change one using the Pythagorean identity. Remember, sine squared plus cosine squared is equal to 1. Now, ideally, if this was positive and these were both positive, we would just replace it with 1, but it's not. One's positive and one's negative here. So, what we're going to do is use this to change everything to either just sines or just cosines when we're given a problem like this. And because we have a sine squared and a sine, we're going to get rid of cosine squared and write it as sine squared. So the way that I'm going to do that is I'm going to subtract sine squared from the Pythagorean identity. And what we end up with is that cosine squared, which I have in this problem, is equal to 1 minus sine squared. And so I can replace this cosine squared, I can replace that guy right there with 1 minus sine squared. So I'm going to write minus sine squared theta. Cosine is now plus 1 minus sine squared. Alright, it was positive, so this remains positive between it. Equals minus sine plus 1. Alright, you're not changing the right side. So now everything is sine. Now we just simplify. This is minus 2 sine squared plus 1 equals negative sine squared. Or sorry, negative sine plus 1. Alright, because this is quadratic, we're going to group everything to one side and then set it equal to 0. This is a negative, so I actually would bring these things over to the other side. That's start off with a positive sine squared. So adding 2 sine squared over, I get a positive 2 sine squared. Alright, this is a negative sine theta. Alright, then the positive one over here, I would have to subtract it to get it to go away on the left, and it would also then go away on the right. So this is what we end up with, and now I'm just going to factor out that common sine function. So that's 0 equals, there's a sine in both of these, so I'm going to do sine theta, and when I factor it out, I'll lose a sine here, so that'll be 2 sine theta, and then here the sine divided by itself is equal to minus 1. Alright, multiplication set equal to 0, I set each of these equal to 0. So sine could be 0 or 2 sine theta minus 1. So here we know what sine is. Here I need to isolate sine. So I'd have a sine theta equals, if I add the 1 over, I'd have a 1. Divide away the 2, I'd have a 1/2. So sine could be 0 or sine could be equal to a half. And now, so I'm looking for angles that make both of these true. Remember, sines are y coordinates. So I'm looking for where's the y coordinate 0, where's the y coordinate 1/2. So this happens when the angle is equal to 0 radians. Right, the y coordinate is 0 again here at pi radians. Right, 2 pi is not underlined here. So it would happen again at 2 pi, but since that's not included, it's just 0 and pi radians for that one. Right, for a half, the sine is the y coordinate, so the y coordinate is a half here at pi over 6. It's also 1/2 here at 5 pi over 6. Alright, so that is again the places where it happens. Alright, I would want to verify that either by graphing or checking it with the calculator. So I'm going to write again, we have to remember that when we have the squared trig functions, we put them in parentheses. So I got a sine x, close that parentheses, squared plus a cosine, close the parentheses, squared. I'm going to hit enter there. And then the next one is negative sine, so negative sine x, close the parentheses, plus 1. Alright, we're looking for the solutions in between 0 and 2 pi, so I'm going to make that my window again, 0 to 2 pi. My x scale, I'm going to make it be pi over 6. Again, I picked that for my scale there because of that being the smallest step, the smallest angle measure here. Alright, my y minimum max, I'm going to initially make it negative 5 and 5 again, but I can zoom in if I need to. Alright, so I'm going to hit graph. So very difficult to see where these intersections are taking place. They are taking place very close together, but I can do a second calculate intersect 5 here and tell it where do I want it to check. So I'm going to do, my first curve is this that left hand side, my second curve is the right hand side, and my guess, I'm just going to get it over here close. So there's my first intersection that it's found. It's actually at pi. So it found this one. It didn't find any of the ones before that. Okay, so analytically, like the procedure that this thing goes through, it sometimes you have to be right on top of it, especially when they're this close together. You may want to zoom in. You could use your zoom button right here and zoom in on some of the intersections. So there's an intersection, looks like right around there. I'm going to zoom in and see if we can see it a little bit better. So it does look like it's crossing it at 0. I'm going to do this procedure again, second calc, intersect. So there's my first curve, second curve, the right hand side. My guess, I'm going to get as close as I can on there. All right, and it found that 0, 1 intersection. So if I did it again over here where they intersect again, there's my first curve, and you can see they're crossing right there. If I just hit enter a couple times, yeah, it did find it. So there's the second one, that's the pi/6. All right, and then you would have to zoom back out, move back over to find those other intersections. Okay, but it can, you can get the all the intersections in there if you just play around with that zoom feature. So it looks like 2 more right there, so I could zoom in on those. I'm going to tell it to zoom in. You have to play around and find where that cursor is. So there's that cursor. It's not always the easiest thing to see on these, especially if you don't have the LCD screens, the new screens. So I'm going to kind of go in between the two, hit enter there, so I get a little tighter fit around this intersection point. You need to have the intersection in the window for the TI to be able to find it. All right, so calculate. There's my first curve. My second curve is that right hand side. If I want to not make it take long, I can just, so there's the pi solution. And then the 5/6, again, I would need to zoom out a little bit because I zoomed in too far. The intersection for TI calculators, the intersection needs to be in the window. All right, so zoom back out. I'm going to zoom back in and just get a tighter fit around that so I can find the fourth one. So there's my cursor kind of right there where that intersection looks to be taking place. I hit enter, zooms back in, and then hopefully this time I can find that fourth and final intersection. All right, so trace, option number 5 there. First curve, second curve. Get it as close as you can for the guess. So there's that one. Okay, and that is 5/6. Again, you would just type it in like on the home screen. 5/6, and there's that same number that I was looking at when I was looking at that graph. Okay, so anyway, that is that's your calculator's kind of clunky way to find the intersection points if you need some help finding them. Okay, you just got to know that that would not be acceptable on the midterm. That decimal, you're going to have to be able to find these exact values. So again, I strongly encourage you to be able to do this analytical procedure.